Okay, folks, this video is purely for my blue level students. Once again, a reminder, blue level means that you didn't feel challenged by the regular lessons. So this is your opportunity to challenge yourself a little bit further. And as always, I'm proud of the students who choose to do this, who really choose to push themselves a little further, just to make sure that they're learning as much as they can and they're not getting they're not just checking boxes and doing what they need to do, but they're going above and beyond, okay? Great. So today we're going to talk about literal equations. Well, what are literal equations? Literal equation is an equation with two or more variables. This last lesson we talked about solving two-step equations, and with two-step equations there's only one variable. There's either x's or a's or b's, but there's no mix of variables, right? Well, you can rewrite a literal equation. We have a couple of examples down at the bottom here of literal equations. You can rewrite literal equations to isolate any one of the variables that you choose, okay? This is called solving for a variable, okay? And it's the same thing we were doing with one and two-step equations, but there's more variables, so you're choosing which variable to solve for. When you rewrite literal equations, you have to divide by a variable or a variable expression. In this lesson, assume that the variable or variable expression is not equal to 0. So you'll notice that this a isn't going to be equal to 0. The reason for that is because dividing by 0 is not defined. It serves for some funky math, not correct math. Okay, cool. So we have some equations here, some examples of our literal equations. First one I'm going to look at here is the ax plus b equals c. Sorry for how messy that is. Now, we have four variables here, and at any time, well, currently, this equation is solved for the variable c. But what if we didn't want the variable c? What if instead we wanted the variable a? Okay, so we're going to pretend we'll solve for x. I like x better. So what do we need to do to solve for x? Well, solve means to isolate, so we need to isolate the x. To isolate the x, we're going to subtract b from both sides. Now we have ax equals, now what is c minus b? Well, we don't know what c is, and we don't know what b is. So what is c minus b? Well, it's c minus b. There's nothing you can do with that. There's no value you can plug in, okay? And to get x by itself, we're going to divide by a because our a is being multiplied. And if you do it to one side, you got to do it to the other. And we have x equals, now what is c minus b over a? Well, it's c minus b over a. You can't simplify that any further, okay? And we have now solved this literal equation for the value of x. Let's try one more example. Okay, let's try one with some numbers here. This right here is actually the equation for the area of a triangle, 1/2 base times height. Well, let's say you knew the area of the triangle. You already know what it is, right? You want to figure out what the base of the triangle is. So let's pretend you know the height, you know the area, and you want to find the base. So in order to find an equation for that, we need to isolate the b. So we're going to get the b by itself. So in order to do that, we're going to first divide by h. Get the h away from the b. Divide by h, which gives us a over h. There's nothing we can do with that. They're two different variables. You can't combine them, which is equal to 1/2 b. 1/2 b. Now, this 1/2 is the only thing we need to get rid of now. You could divide by 1/2 because it's multiplied, but a far, far, far easier way than dividing by 1/2 is multiplying by 2. Why is that? Because 2 times 1/2 is just 1, right? You do it to one side, got to do it to the other. And if you multiply an integer by a fraction, you can go ahead and just put it in the top, which is 2a divided by h is equal to b. Now, if you have a triangle, you know the area, and you know the height, you can find the base. We've just now created this formula. Last thing we should do, good habit to get into, is put the variable we found on the left. Same exact equation, we just flipped it around. This is considered more appropriate, okay? Cool. Now, moving to our next slide, we are going to clear the whole board. Now, this formula right here, this will be our last example. This formula right here is the formula for finding the temperature in Fahrenheit if you already know what it is in Celsius, okay? Now in the States, we use Fahrenheit, right? But in many other countries, they use Celsius. Most other countries. The States is probably one of the very few that decides to put their foot down on that. But what if instead of finding Fahrenheit, what if we wanted to find Celsius? What if we wanted to input the value of a temperature in America and figure out what they would say that temperature is in the UK or Australia or South Africa, China, somewhere else, right? In order to do that, we need to isolate this C. To isolate the C, just like solving two-step equations, we work from the outside into the C, so we got to get rid of this 32 first. Now, what is F minus 32? We have no idea, right? So we're just going to write F minus 32 is equal to 9/5 C, because the 32's cancel out. Now, to get the C by itself, there are a lot of ways we can do this, but the easiest way, we could divide by 9/5, right? But that is going to be a nightmare. We do not want to do that. Instead, we're going to do it as easy as possible, which is multiplying by the reciprocal. 5/9 just means flipping it. The reciprocal means flipped. Now, if you do it to one side, you got to do it to the other. But because we're multiplying the whole side over here by 5/9, we have to multiply the whole side over here by 5/9. Okay? These cancel out, giving us 5/9 F minus 32. So now we can plug in a Fahrenheit and get the temperature in Celsius. And again, we'll put the Celsius over here and 5/9. You could, if you wanted to, distribute this fraction and it would still be correct. But 5/9 times negative 32, it's going to be a big messy fraction. It wouldn't be any nicer, I don't think. So we'll just keep this just like this, okay? And that is our literal equation that has now been solved for C. Okay? And here we go. We have the Celsius to Fahrenheit and Fahrenheit to Celsius, so we can see them side by side. Okay, cool. And you could easily plug in 35 degrees Celsius or 50 degrees Fahrenheit to find the equivalent value in the other unit. Okay, that is our blue presentation for today. As always, you will be given an assignment on Google Classroom. If you choose to do this, and I hope that you do, you are going to take a picture of it and send it to me in email. Okay, blue people are the only people that email me their work are the blue individuals, because there's probably going to be a little bit less of them. Okay, I appreciate your hard work, and you all enjoy the rest of your day.